Good evening to one and all. Today we are going to discuss about nomenclature of alicyclic compound. Nomenclature of alicyclic compounds. It is very easy. Alicyclic compound is nothing but actually hydrocarbons are classified into two types, that is open chain hydrocarbon, closed chain hydrocarbon. Open chain hydrocarbon is nothing but when the carbon atoms are connected with each other in a straight chain or branch chain in a open manner is called open chain hydrocarbon. It is also called acyclic hydrocarbon. And second one is cyclic hydrocarbon. When the carbon atoms are connected with each other in a closed manner, ring manner, is called closed chain. These closed chain hydrocarbons are classified into two types: homocyclic hydrocarbon, heterocyclic hydrocarbon. Homocyclic hydrocarbon is also called carbocyclic. What is the statement of homocyclic hydrocarbon, sir? If the cyclic compound containing all the atoms are same, if the ring containing at least all the atoms only same kind of atoms, that means if the ring containing all are carbon atoms. What is alicyclic? These homocyclic compounds are classified into two types, that is alicyclic homocyclic, aromatic homocyclic. Okay, aliphatic homocyclic means the cyclic compound containing one or more rings of three or more carbon atoms. If you take here, already the valency of carbon is tetravalency. Carbon can form 4 bonds. When the carbon atoms are connected with each other in a closed manner, the compound containing one or more rings of 3 or more carbon atoms which are resembles with aliphatic characteristics is called alicyclic homocyclic compound. If the ring containing at least 3 carbons, then the cyclic compound is called 3-membered ring. 3 carbon atom, 4-membered ring. If you take 5 carbon atoms, 5-membered ring. 6 carbon, 6-membered ring. 7 carbons, 7-membered ring. 8 carbons, 8-membered ring. Like that. Okay, what is the definition of a alicyclic homocyclic compound? Means if the cyclic compound containing one or more rings of 3 or more carbon atoms. If the alicyclic compound containing at least 3 or more carbon atoms, 1 or more rings, is called alicyclic homocyclic compounds. How to give the nomenclature of alicyclic compounds? Rule number 1. There are various rules are there. Rule number 1. Point number 1 here. What is rule number 1, sir? Here. Okay, the name of alicyclic compound is obtained by primary prefix cyclo is added before root word. If the ring containing all are single covalent bonds, we can use the end of the word ena. If the ring containing double covalent bond, in, or if you take triple covalent bond, ein. Okay, rule number 1 here. If the cyclic compound, the name of the cyclic compound is obtained The cyclic compound, the name of the cyclic compounds are obtained by adding a primary prefix cyclo to the before root word, and if the ring containing at least one single covalent bond between two carbon atoms N, at least one double covalent bond between two carbon atoms N, at least one triple covalent bond between two carbon atoms N. So that's why here name is cyclo, number of carbon atoms 3, prop, N, all are single bonds. So this name of the compound is cyclopropane. Cyclo, primary prefix. How many carbons here? 3 carbons. Prop, all are single bonds. N, cyclopropane. This is called cyclobutane. This is called cyclopentane. If you take 6 carbon, cyclohexane, cycloheptane, 7 carbons. This is the rule number 1. I hope it is clear. And rule number 2. What is rule number 2, sir, here? If the cyclic compound containing one substituents, mono-substituent cyclic compounds. Okay, the position of substituents can be mentioned. 2 or more substituents, we can use position of substituents. The numbering starts with either clockwise direction or anti-clockwise direction by using of lowest sum rule. Once again repeat. If only one substituent is attached to the ring, if only one substituents in the ring, for example cyclopropane, only CH3 is there, we can mention only the position of the substituent. 1 methyl cyclopropane. If you take cyclobutane, CH2 CH3, 1 ethyl cyclobutane, like that. If only one substituent is attached to the ring, its position is mentioned. Its position is mentioned. If 2 or more substituents are present in the ring, in case 2 or more substituents are present, their positions are indicated by Arabic numbers 1, 2, 3. Like that, if you take cyclopropane, Cl, 1, 2. Here also Cl is there, 3. Position of the substituents can be mentioned with Arabic numbers. Arabic number is nothing but numbers 1, 2, 3, like that. Arabic numbers. I hope it is clear. Which are used for numbering of carbon atoms in the ring. The numbering is done in such a way, either clockwise either clockwise direction or anti-clockwise direction, that substituents get lowest set of locants. All other rules relating to the aliphatic or acyclic are then followed. For example, here cyclopentane. In the cyclopentane containing CH2, CH2, CH3. Okay, 1 propyl cyclobutane. 1 propyl cyclo pent, all are single bonds, and if you take 6-member ring, CH2, CH3, 1 ethyl cyclohexane. I hope it is clear. This is rule number 2. In case rule number 3, you can observe here, rule number 3. If the ring containing less number of carbon atoms, if the ring having less number of carbon atoms, then the substituents are then the side chain. Then the cyclic ring act as a substituent. Then the substituent name of cyclic ring is called cycloalkyl substituent. Once again, repeat here. If the cyclic ring contains less number of carbon atoms than the alkyl group or than the side chain attached to it, the compound is named as the derivative of alkane. The compound is named as a derivative of alkane, and the ring is treated as a cycloalkyl substituent, and the ring is treated as a cycloalkyl substituent. It is named as the derivative of cycloalkane. For example, if you take here cyclopropane, CH2, 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 CH3. 1, 2, 3, 4. Okay, this is act as a, if the ring containing less number of carbon atom than the side chain or alkyl substituent, it is acted as substituent. Okay, what is the name of this one? Cyclopropyl butane. If you take cyclobutane, 1, 2, 3, 4, 5. CH2, 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 CH3. 1, 2, 3, 4, 5, 6. That means 1 cyclobutyl, 1 cyclobutyl hexane. I hope it is clear. Third one. Or if you take 5-member ring, 1, 2, 3, 4, 5, 6. 1 cyclopentyl hexane. In case same number is there, sir, cyclopropane 1, 2, 3, 1 CH2, CH2, CH3. Okay, that time it is act as substituent. 1 propyl cyclopropane only. If the cyclic compound containing a ring containing less number of carbon than the substituent, that is side chain or alkyl group, then the ring act as a derivative of cyclic group, that is called substituent characteristic, that is called cycloalkyl substituent. I hope it is clear. If you take one more rule here, in case of side chain containing, either multiple bond, in case side chain containing multiple bond or functional group, the cyclic compound or ring act as a substituent, that is called cycloalkyl substituent. For example, this is called cyclohexane, CH double bond CH2, cyclopentane, CH2 single bond CH double bond CH2, cyclohexane, CH2 CH2 OH, cyclopropane, CH2COHO, cyclobutane, CH2COOH, like that is there. These are all compounds. Okay, this time, those type of compounds, it is act as substituent, cyclohexyl ethene. Okay, 1, 2, 3. Cyclopentyl propene, prop 1 in, here also eth 1 in. This one 2 cyclo sorry, 2 cyclohexyl. Here 3 cyclohexyl. Here 3 cyclohexyl ethanol. This one 2 cyclopropyl ethane carbaldehyde. Ethane carbaldehyde. This one 2 cyclobutyl ethane carbaldehyde. So carboxylic acid. Here one more point. If the multiple bond or some other substituents are present in the ring, in case if multiple bond or substituents in the ring contains, ring attach cheyandi. If a multiple bond or some other substituents are present in the ring, the numbering is done in such a way. So, if the molecule containing multiple bond and as well as a substituent, the numbering is done in such a way so as to assign the lowest number to the multiple bond only. If the ring containing both multiple bonds and as well as the substituents, the numbering is always lowest locant position of this multiple bond only. That's either double bond or triple bond. So here, once again repeat. If multiple bond or other substituents in the ring, the numbering is always assigned as the lowest number of multiple bond. For example, if you take here cyclohexane, here double bond is there, here nitro group is there. Numbering is always starts with here only. Cyclohexane is there, here Br is there, numbering here. Numbering is always starts with here also. That means 3 nitro, cyclohexanone, 2 bromo, cyclohexene. Or if you take one more example here, the numbering starts with always 1, 2, 3 trichloro cyclobutadiene. This is information about rule number 4. And rule number 5 is, rule number 5 here. In case some functional group along with substituents present in the ring, in case functional group along with substituents in the ring, the numbering of carbon atoms should be done in a such a way of functional lowest position of the functional group gets lowest number. Simply, in case some functional group along with substituents in the ring, if the cyclic compound containing both functional groups and as well as the substituents, the position of the functional group is always lowest possible number. Especially if you take chain terminating groups like carboxylic acid, the substitute suffix name is carboxylic acid. If you take aldehyde, the substitute suffix name of aldehyde is carbaldehyde. If you take cyanide, the substitute suffix name of cyanide is carbonitrile. If you take ester, the substitute suffix name of ester is alkyl carboxylate. If you take acid halide COCl, the substitute suffix name of acid halide is carbonyl halide. If you take amide, the substitute suffix name of amide is carboxamide. These are the substitute suffix names. In case if you take cyclohexane, Here OH is there. Here CH3 is there. Methyl group. So take the cyclohexane. Here either aldehyde is there. Here Cl is there. In case if you take multiple bonds also is there. If the ring containing either ketone group, CH3 group, and also multiple bond is there. How to give the name of this compound? So take here, the numbering is always starts with functional group onwards. How to give the name of this compound? 4-methyl cyclohexane 2-in 1-ol. This is 1, 2, 3, 4, 5, 6. 5-chloro cyclohex 2-in 1-carbaldehyde. This one 1, 2, 3, 3-methyl cyclohex 2-in 1-on. Okay, this is information about rule number 5. I hope it is clear. Still some more compounds are there. If you take here COOH, if you take one more substituent, nitro group is there, NO2 group. Okay, how to write the name of the compound? Always 3-nitro cyclohex 2-in 1-carboxylic acid. Or if you take one more example, a 5-membered ring with here CH3 CONH2, amide functional group, CONH2. Here if you take here C2H5, okay, 1, 2, 2-ethyl cyclopent, 2-ethyl cyclopentane 1-carboxamide, 2-ethyl cyclopentane 1-carboxamide, etc. And finally, last rule is rule number 7. Rule number 6. If the cyclic compound containing, try substitute cyclic compound in a given compound. Here methyl is there. The numbering is always starts with alphabetical order. First priority, second priority, third, 4, 5, 6. Okay, 1-bromo, 3-chloro, 5-methyl cyclohexane. And last rule here. Okay, one more functional group here you can observe. Same functional group is repeated. Same substituent is repeated. CH3, CH3, CH3. Okay, the numbering is always starts with the lowest sum rule. The lowest locate position. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, 1, 3, 5. Trimethyl cyclohexane. If the cyclic compound containing same kind of atoms or different kind of substituents are attached to the cyclic compound, okay, different substituents attached to the cyclic compound, we can use alphabetical order. The same type of atoms we can use numerical prefix. And last one is rule number 7. That is, if the ring containing two different functional groups, if you take aldehyde OH group, or if you take COOH, or if you take aldehyde, or if you take CHO, C double bond O, or CONH2, or if you take cyano. How to give the name of this one? In these two functional groups, one of the functional group act as a principal functional group, another one act as a substituent. If the ring containing two different functional groups, okay, one of the functional group act as a principal functional group, that is called we should write the secondary prefix name, and another one act as a prefix. The prefix name of alcohol is hydroxy. Okay, 2-hydroxy cyclohexane 1-carbaldehyde. Substitutive suffix name we should write. This one 2-formyl cyclohexane 1-carboxylic acid. Cyano 2-cyano cyclohexane 1-carbaldehyde. Okay, this is information about what are the rules of nomenclature of alicyclic compounds. I hope it is clear. Thank you. Now I would like to discuss about another concept, how to give the nomenclature of bicyclic compounds. The nomenclature of bicyclo and spiro compounds. What is bicyclic compounds are? The cyclic compound containing at least more than one compound. If the ring containing at least two rings, if the closed chain compounds contain at least two rings are called bicyclic. Both spiro and bicyclo containing two cyclic compounds. Okay, here the certain cyclic compounds containing two or more rings. Certain cyclic compounds containing two or more rings is called either spiro or bicyclic compounds. Here, what is bicyclo compounds are? When the two cyclic compounds are connected with each other by a tertiary carbon atom. If you take it is a 4-membered ring, this is a 3-membered ring. When the two cyclic compounds are connected by a quaternary carbon, is called spiro compounds. When the two cyclic compounds are connected by tertiary carbon atoms, at least two atoms, that is called bicyclic compounds. Once again repeat, what is bicyclic compound, what is spiro compounds? If the certain cyclic compounds containing at least two rings, certain cyclic compounds containing two or more rings is called spiro and bicyclic compound. When the two cyclic compounds are connected by two common atoms, that is called bridgehead carbon atoms. Okay, these two cyclopropanos, cyclobutanos, this is cyclopropane, cyclobutane. These two are connected by common atoms. Common carbon atoms are called bridgehead carbon atoms. Bridgehead carbon atom. Once again repeat. Rule number 1 here, how to give the nomenclature of bicyclic compounds. Bicyclic compounds are classified in two types. Bridged bicyclic compounds and as well as a fused bicyclic compound. This is called fused bicyclic compound. If you take this is called bridge. This is called fused. If you take 6-member ring, bridged bicyclic compound. This is called fused bicyclic compound. How to write the name of the bicyclic compounds are? The name of the bicyclic compound is obtained from adding a primary prefix. The name of the IUPAC name of the bicyclic compound is obtained by adding a primary prefix to the root word bicyclo. And also we should write the square bracket to of the both the rings. Here the position of the carbon atoms in the two rings and as well as the bridgehead carbon atoms. Then followed by root word, the ring containing all are single bonds and all are the ring containing all are single bonds and double bond in, triple bond in, at least one double bond in, at least one triple bond in. In case finally primary suffix or functional group. This is the rule number 1. The name of the bicyclic compound is obtained from adding a primary prefix bicyclo before root word. And also the position of the carbon atoms in the ring, we should write the position. You take in this compound, these two are bridgehead carbon atoms. Here first position, second position, here one position. Okay, that means we should write the position, left side position 2 position, dot, here bridgehead carbon, here this side 1 position, here 0. So bicyclo 2, 1, 0. Total number of carbon atoms 1, 2, 3, 4, 5. Pentane, that's enough. Pent plus N, all are single bonds. Okay, like that, if you take one more example here, if you take here, five-membered ring, four-membered ring. These two are bridgehead carbon atoms. The numbering starts with descending order. Descending is nothing but big to small. Big to small. 1, 2, 3, 4, 5, 6, 7. Total number of carbon atoms 7. Okay, how to give the name of this compound? The name of the bicyclic compound is obtained by adding of primary prefix bicyclo to the root word and the position of atoms carbon atom 1, 2, 3. 3 dot, here 2 dots. How many positions? There is no position here, 0. 7 carbon means heptane. I hope it is clear. If you take one more example here, cyclohexane, cyclopropane, cyclohexane, cyclobutane, cyclohexane, cyclopentane. Okay, the numbering starts with bridgehead carbon atom onwards. That's why here 7 carbons. Okay, what is the name of this one? Bicyclo 1, 2, 3, 4. 4 dots, 1 dot, 0. Heptane. This one 1, 2, 3, 4, 5, 6, 7. 7, 6, 7, 8. Okay, what is the name of this one? Bicyclo The name of this one is bicyclo 1, 2, 3, 4. 4 dots, 2 dots, 0. Octane. This one 1, 2, 3, 4, 5, 6, 7, 8, 9. Bicyclo 1, 2, 3, 4. 4 dot, 1, 2, 3. 3 dots, 0. Nonane. Like that. If you take either substituents or multiple bonds or functional groups in the bicyclic compound, the numbering is always starts with bridgehead carbon atoms to big molecule to small molecule. we should write the position of substituents, and as well as the position of multiple bond, position of functional group, as it is rules before rules as it is follow only. I hope it is clear. Same manner for spiro compounds also. If you take some more examples here, cyclohexane, this is called bridgehead. This is called actually bridged bicyclic compound. And also if you take one more bridgehead carbon, that is called bridged bicyclic compound. The numbering starts with okay, these are the bridged carbon atoms: 1, 2, 3, 4, 5, 6, 7. Okay, these two are substituents. It is also substituents. 1, 7, 7 trimethyl bicyclo. Position of it: 1, 2 positions here, 2 positions here, 1 position. Total number of carbon atoms 7. Heptane. What is the name of that compound? 1, 7, 7. Like that. If you take this one, okay, what is the name of this compound? If you take here, substituent is here, NO2 is there. Okay, the numbering starts with here onwards. 7, 8 carbons are there. 6 nitro bicyclo. 1, 2 dot, here also 2. Total number of carbon 8. Octane. I hope it is clear. So how to give the nomenclature of spiro compounds? Now how to give the nomenclature of spiro compounds already you know. This is called cyclopropane. It is also called cyclopropane. Cyclobutane, cyclopropane, cyclobutane, cyclopentane, cyclohexane, cyclopropane. These are all when the two cyclic compounds are connected by a quaternary carbon, is called spiro compound. How to give the name of this compound? So the name of the spiro compound is obtained by adding a primary prefix spiro and as well as this position of the rings and also plus root word plus primary suffix. What is the name of this one? The numbering starts with small ring to big ring. Total number of carbon atoms 5. That is spiro 2.2 pentane. If you take this one, the numbering starts with small ring 2. The numbering starts with small ring to big ring. Total number of carbon atoms 8. Spiro, small ring positions 2 positions, big ring positions 5 position. Total number of carbons 8. Octane. Here it is small ring, big ring. 1, 2, 3, 4, 5, 6, 7, 8. Spiro. Small ring how many positions? 3 positions. Big ring 1, 2, 3, 4. 4. Total number of carbon atoms 8. Octane. Okay, this one. Small ring 1, 2, 3, 4, 5, 6. 6 means hepto. Spiro 2 dot 3 dot 3. 1, 2, 3, 4, 5, 6. Hexane. So this is information about how to give the nomenclature of spiro compound. I hope it is clear. I hope it is clear. For example, now I am taking last example here for spiro compound. Either 5-membered ring and 4-membered ring. How to give the numbering? Always small ring to big ring. Okay, what is the name of this one? Spiro. Small ring positions 3, big ring position 4. Total number of carbon atoms 8. Octane. I hope it is clear. If you take the nomenclature of aromatic compounds, how to give the name of the aromatic compounds? Aromatic compounds, the basic name of aromatic compound is aroma. That means benzene. The basic name of, how to write the nomenclature of aromatic compounds. The basic name of the aromatic compound is benzene. The UPSC nomenclature has taken prime position. The aromatic hydrocarbon is also called arenes. Okay, benzene. What is aromatic compound? The compound containing at least one benzene ring. Then the compounds are called, or if the aromatic compound, the cyclic compound containing at least a 6-membered ring with alternate single and double bond, or 2 or more fused rings. Conjugation, cyclic, planar, and also conjugation takes place. It can obey occur 4n plus 2 5. These are all aromaticity, anti-aromaticity, anti-aromatic. 4 and 5 rule, anti-aromatic. Okay, benzene, this name is benzene. To take this name is called naphthalene. This name is called anthracene. This is called phenanthrene. Benzene, naphthalene, anthracene, phenanthrene. Now, the ring containing, if the aromatic compound containing at least one substituent, rule number 1 here. If the aromatic compound containing only one substituent, it is called monosubstitute. Monosubstituted benzene. That is nothing but when the benzene ring containing at least one substituent. You take alkyl is connected to the benzene, alkyl benzene. Halo is connected to the benzene ring, halobenzene. When methoxy group is connected to the benzene is called methoxybenzene. Nitro group is connected to the benzene is called nitrobenzene. This is called nitrobenzene. This is called alkoxybenzene. This is called halobenzene. This is called alkyl benzene. I hope it is clear. What is monosubstituted benzene? Monosubstituted benzene is nothing but if the benzene ring containing at least one substituent, then the benzene rings are called monosubstituted benzene. For example, here you can observe. Now I am taking methyl. It is a benzene. It is connected to the methyl group. Methyl benzene. Methyl benzene. It is also called toluene. If you take C2H5, ethyl benzene, C3H7, propyl benzene. If you take OCH3, methoxybenzene, it is also called anisole. Okay, methoxybenzene, ethoxybenzene, propoxybenzene, etc. Halogens, if you take fluorine is connected to the benzene, fluorobenzene. Chlorine is connected to the benzene, chlorobenzene. Br is connected to the benzene is called bromobenzene. Not only this one, if you take functional groups connected to the benzene ring. If you take functional groups like OH group, if you take here, OH group is connected to the benzene is called phenol. CHO is connected to the benzene is called, this is called phenol. This is called carbaldehyde or simply benzaldehyde. Benzaldehyde. If you take here, COOH group is connected to the benzene, benzoic acid. When NH2 group is connected to the benzene is called aniline. Cyanide group is connected to cyanobenzene. Aldehyde, carbaldehyde, benzaldehyde, etc. These are all mono-substituted. Benzenes. I hope it is clear. Okay, now second one is di-substituted. How to give the nomenclature of aromatic containing di-substituted. For example, if you take second one is di-substituted benzene. Di-substituted benzene is nothing but substituents of two substituents are attached to the benzene ring. Okay, this is the most important here. If you take here benzene ring, here halo, here also halo. Benzene, halo. Here benzene ring, chloro, here chloro. We can observe here, if the compound containing substituent position, okay, 1,2 dichlorobenzene is called IUPAC, or it is also called here 1,2 positions are called ortho position. Here this name is called 1, 2, 3 1,3 dichlorobenzene. Here 1,3 positions are called meta position. 1, 2, 3, 4 1,4 dichlorobenzene. This 1,4 positions are called para position. Okay, that means here ortho dichlorobenzene, meta dichlorobenzene, para dichlorobenzene also used. Okay, in benzene ring, if the benzene ring containing two substituent, okay, 1,2 positions are called ortho position. Okay, 1,3 positions are called meta position. 1,4 positions are called para position. Among in these three positions, para positions are more stable. I hope it is clear. And also some names here is there. Okay, when methyl group is connected to benzene ring is called methyl benzene, or it is also called toluene. Methoxy group is connected to the benzene is called methoxybenzene. Br is connected to the benzene, bromobenzene. Ethyl group ethyl benzene. Isopropyl group is also called isopropyl. You take it is a benzene ring. Isopropyl. This is called isopropyl. This group is connected to the benzene, that is called cumene. It is also called isopropyl benzene. Or if you take ethylene benzene, a benzene ring is there. This is called styrene arom ethyl benzene. If you take same number of atoms are there. In case benzene is there, here substituent CH2, 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 1, 2, 3, 4, 5, 6. This is same number of carbon atoms present in the ring. It is a ring act as a substituent. The benzene ring act as a substituent. It is called phenyl. 1 phenyl heptane. 7 carbons. 1, 2, 3, 4, 5, 6. 7 carbons are there. This benzene ring act as a substituent, that is called phenyl or benzene. I hope it is clear. In case different substituents being connected to the benzene ring, the substituents of base compound is assigned as a number 1. Okay, base compound is nothing but here, in case you can observe here, if the ring containing 2 or more substituents, Cl, we can use numerical prefix here. When aromatic compound 2 or more functional groups it's named as a derivative of the compound with principal functional group at position. That means if the benzene ring containing two or more functional groups, if you take COOH, OH is there. Okay, the numbering is always principal functional group. That is a carboxylic acid is a principal functional group. The numbering is always starts with here, and this is act as a prefix 2-hydroxy benzoic acid. Like that we should write. Or if you take the substituent of base compound is assigned number 1, then the direction of numbering is chosen such that the next substituent gets lowest number. That's why it is used as a alphabetical order. If you take here alphabetical order, to take benzene, this is called base compound, toluene or methyl benzene. Different substituents are connected to the benzene. Different substituents like here, either nitro groups, NO2 group, here also NO2 group, here also NO2 group. Okay, this is base compound 1, 2, 3, 4, 5, 6. Okay, 2, 4, 6 trimethyl toluene or 2, 4, 6 trinitro methyl benzene, or sorry, NO2 means nitro, trinitro toluene, or base name of that compound is toluene or methyl benzene, toluene. Like that, if you take one more compound here, if the compound containing different substituents, here C2H5 ethyl, here fluoro, here methoxy. Now this is the base compound. Okay, here ethyl E, this is called fluoro, that's why 4 ethyl, 2 fluoro anisole. Base name is, the base name of that compound is base compound anisole. If the benzene ring is named as a substituents, if the ring act as a, if the benzene ring containing side chain containing functional group, if the ring containing side chain containing functional groups, for example, it is a benzene ring, CH2OH is there, the numbering starts, this is act as a substituent. The substituent name of benzene is called phenyl or aryl. Okay, 2-phenyl ethanol. What is the name of that one? 2-phenyl ethanol. Or if you take substituents or benzene, if benzene ring is named as a substituent, if it is named as a phenyl, if you take some more examples here, benzene, here CH2, Cl is there. Okay, 1-phenyl, 1-phenyl chlorophenyl methane. Sorry, chlorophenyl methane. And last example you can observe here, the ring containing multiple bonds, the ring side chain containing multiple bonds, 1, 2, 2-phenyl ethene, 2-phenyl ethene. Okay, I hope it is clear how to give the nomenclature of aromatic compounds. Thank you one and all. Okay, this video is useful for you. So please subscribe my channel. Thank you one and all.